Welcome. Today we're going to analyze three triangles to find their sine, cosine, and tangent values. This is a right triangle. It is an isosceles triangle. This is how we find these values for it. We'll assume that the hypotenuse for all of these triangles is 1. Then we have to find these lengths right here. And remembering from the Pythagorean theorem, a squared plus b squared equals c squared. What we know is that we'll just call this a, this one is b. What we know is that a equals b because this is an isosceles triangle. So what we have is a squared plus a squared equals 1 squared. 2a squared equals 1. A squared equals 1 over 2. A equals the square root of 1 over 2. Going a little bit further, a equals the square root of 1 divided by the square root of 2, which means 1 divided by the square root of 2. Then we can go even further, multiply the top and bottom by square root of 2, and we get a equals square root of 2 over square root of 2 times square root of 2, which ends up being square root of 2 over 2. So what we know here, if this is 1, this is square root of 2 over 2. This is square root of 2 over 2. So now let's look at the sine. Here's theta right here. So we'll do sine is this divided by that. So square root of 2 over 2 divided by 1. Sine of 45 degrees is square root of 2 over 2. Cosine of 45 degrees is square root of 2 over 2. The tangent, opposite divided by adjacent, these ones are identical. The tangent of 45 degrees is 1. Now I'll erase it and we'll look at a different triangle. Now let's analyze this triangle. This is called an equilateral triangle because all of the side lengths are 1. You have 1, 1, and 1. But how can I make this into something that resembles a right triangle? All I'll do is just grip it like that. Now we have a right triangle here. And what we know is this is 1 from before. This isn't 1 on the bottom, this is 1/2 because it was 1, but we chopped it in half. How do we find this one? I'll call this b. So we know that a equals 1/2. We don't know b, but we know c equals 1. So we'll write 1/2 squared plus b squared equals 1. So we'll square this. 1 over 4 plus b squared equals 1. Put this onto the other side. B squared equals 3 over 4. B equals the square root of 3 over 4. Square root of 3 over square root of 4, which ends up being, after you square root the 4, square root of 3 over 2. So we'll replace this by square root of 3 over 2. So now let's try to find these trigonometric values. Sine, remembering that theta is right here in the lower left. Sine of theta, in this case theta is 60 degrees. Sine of 60 degrees, square root of 3 over 2. Cosine, 1 over 2. The tangent of 60 degrees is square root of 3 over 2 divided by 1 over 2. And what happens is these 2's cancel, so it's simply square root of 3. Now I'll erase this one and we'll look at a very easy triangle. The last right triangle we'll look at today is this one. Now I know this doesn't look like a triangle, but in this case, theta equals 0, and the hypotenuse is 1. Here what we have is we have the adjacent is 1, and the opposite is 0. So how do we find the sine of this? Opposite over hypotenuse. So the sine of 0 is 0 divided by 1, which is 0. The cosine is 1 divided by 1. And the tangent is 0. Once you understand these three triangles, you can then calculate all of the trigonometric values you'll need in your trigonometry class. It's these three. And we've derived a way to figure out what all of the values are. So good luck with your trigonometry class. Hooray! Hooray!